Our term project focused on the CYK algorithm. Our group members were Zach, Ben, Drew, and Travis. So our paper information, the first paper we used was called CYK Algorithm. It was published in the International Journal of Scientific Research, Engineering, and Technology, and it was published in August of 2012. The second paper we used is called Great Algorithms, CYK, and it was published September 1st of 2013. So some background. The CYK algorithm was named after Koch, Younger, and Cosme. The algorithm for deciding if a string is in a context-free language. The grammar must be in Chomsky normal form, and the string must be provided. If both are provided, the algorithm will return true if and only if the string is an element of the language. Worst case scenario for performance is O(n) cubed times the length times g. N is the length of the parsing string, and g is the size of the Chomsky normal form grammar. But since it's O(n) cubed times a linear, the linear can be ignored, and it's just n cubed. What is Chomsky normal form? Just a brief explanation we've already went over in class, but this context-free grammar is in Chomsky normal form when every rule is in the form A produces BC, or A produces lowercase a, where lowercase a is a terminal, and A, B, and C are variables. B and C are not the start variables also.
So the CYK algorithm is summarized in this way, where the user inputs a string to begin with, as well as a grammar, and then the program creates a matrix, a triangle matrix, and then looks at every possible substring of the inputted string to see if the production is in the grammar. And once the program completes checking for each substring, it can determine if the entire string is in the language generated by the context-free grammar. Other modifications to the CYK algorithm: the CYK algorithm with non-Chomsky normal form grammar, parse strings using weighted and stochastic context-free grammars. We chose to implement the CYK algorithm as it is the basis for all other algorithms.
I will now briefly go over an example of the CYK algorithm. Given the string BAA, the triangular table can be constructed. The height of the triangular table is equal to the length of the string. As you can see, our string length is 5, and the triangular table is 5 blocks high and 5 blocks wide. The algorithm starts by checking the first terminating variable, which in this case is B. Looking at the grammar, you can notice that the terminating variable B can only be generated by the production B. Therefore, an uppercase B is placed in the box above it. Doing the same thing for the next terminating variable A, you can notice that both the productions A and C can generate it. Thus, those values are placed in the box above A. The same concept can be followed for the rest of the row. Once row 2 is reached, the Cartesian product of the first two boxes in row 1 are used. For instance, B is multiplied first by A and then multiplied by C, giving the values BA and BC. Then, we check the first value, BA, and notice that it can be generated by the production A. And then we check the value BC, which can be generated by the production S. Then an S and an A are added to the first column of the second row. This basic process continues for the rest of the triangle, giving us the complete triangular table that you can see on the slide. The last row, which in this problem is the fifth row, needs to contain the starting production in order for the string to be in the grammar. In this case, our starting variable S is located in the last row, so it is located in the grammar.
Here's a description of some of our code. Basically, once the left and right hand sides are parsed on either side of the pipe, it's passed to these functions that check to make sure that they're in Chomsky normal form. This section of the code initializes the matrix based on how many characters are in the inputted string. Now we have a demonstration. Here we're going to see that when we hit enter, it's going to tell us that the string can be generated, and it's going to give us the triangular graph. With this user entered string, the string cannot be generated,